For our last page of notes in section 1.1, we're just going to do some more practice determining whether something is a function or not, domain and range, and then we introduce this idea of a specific type of function called one-to-one. So for these first couple examples, I'm just asked, is this relationship, is this graph considered a function? And I'm going to use the idea that we discovered up above of the vertical line test. So on this first one, if you take your pen or pencil and you draw vertical lines through any x value, you'll see that you hit this curve one time and only one time, which means, yes, it is a function. When I talk about domain here, do you see how it's not just separate points like we had up here? Since it's not just separate points, instead of using our little squiggly bracket, we're actually going to use our parentheses. Okay, so when I talk about domain, again, I'm talking about all of the possible x values. If I look at this graph, I see that I have x values of -4, -3, -2, -1, 0, 1, 2, 3, and 4. But I also notice that there are arrows on the left and right side of this graph, meaning that this graph goes forever to the left and forever to the right. So the smallest number in possible existence forever to the left on this number line is actually -infinity. And the biggest number forever to the right on this number line is +infinity. This means that all possible x's in existence can exist on this function. When I look at the range, I'm looking at the y values. So looking up and down, I see that I have values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then these arrows going up forever. So I'm kind of thinking the same way about my domain with my range. It goes up forever to infinity. However, it stops at 0. It does not go further down than 0. So I'm actually going to put a hard bracket here, and again, we'll talk about this more in class. But your range goes from 0 to infinity here. All right, moving on to the next one. First, function or not, I do my vertical line test, and if I do the vertical line test in the right spot, you'll see that this vertical line hits this curve once, twice, 3 times, meaning no, it is not a function. For my domain, again, I'm looking at the x values. I see that my arrow is pointing forever to the left and forever to the right, meaning my domain is from negative to +infinity. And I know it looks like these arrows are just pointing left and right, but this arrow on the left is actually also pointing down, and this arrow on the right is actually also pointing up, meaning that my range, my y values, also go from -infinity to +infinity. All right, and lastly, this table. I can't really do a vertical line test here, so instead I'm going to look and see if these x values give me one and only one unique y value. So I look at this x value of 3. It gives me the one y value of 5. But then if I look further down on my table, I see the x value of 3 again, with a different y value this time. So if you wanted to think about it on a graph, here's your x value of 3, and it gives you the y values of both 2 and 5, meaning it would not pass the vertical line test. It is not a function. And similarly to the examples on the second page, since it's not a continuous function, it's just data points, your domain and range are going to get the squiggly brackets, and you're just going to write in order from least to greatest your x values for the domain and your y values for the range. All right, and the last piece of these notes for 1.1 is this idea of one-to-one functions. So let's read together. It says, a function is one-to-one, or 1-1, if, in addition to every domain value yielding a unique range value, each element of the range also yields a unique element of the domain. Said differently, x and y have a one-to-one correspondence. X uniquely determines y, and y uniquely determines x. On a graph, a function is one-to-one if it passes both the vertical line test and the horizontal line test. So it's very similar to what we were doing with just functions, but now we're testing both vertically and horizontally. So choose the best description of the relation below. It's either just a relation, so it's not a function, or it's a function, but maybe it's not one-to-one, or it's both a one-to-one and a function. So it might actually be easier to start with these bottom examples. We're not actually going to talk about domain and range of these yet. We'll come back to those. But if I look at this first example, vertical line test already shows me that it's not even a function. So I'm not even going to have to test the one-to-oneness of this. If it's not a function, I'm just going to call it a relation. Down here, though, I'm going to draw my vertical lines. Passes the vertical line test. So I know it is a function. Once I know it's a function, I'm going to test its one-to-oneness. So I'll draw my horizontal lines. And look at that, each horizontal line only hits my curve once. So it's a one-to-one function. Lastly, again, I'm going to start with my vertical line test. Those vertical lines only hit my little curve once, so it is a function. If I draw my horizontal lines, so far it only hits once. But down here, we start hitting our curve twice when we draw horizontal lines. So it is a non-one-to-one function. I always think looking at the graphs is a little bit easier than looking at the mapping diagrams. With our mapping diagrams, remember we have the domain, or our x's in the first one, and our range, y's in the second one. So if we think about these as graphs, 0 only goes to 7, 2 only goes to 3, 5 only goes to 3, and 6 only goes to 0. So each of these x's gives me one and only one y. However, if we look here, this one y gives me two different x's, meaning it's a function, but it's non-one-to-one. If we look at this next one, 0 only gives me 7, 2 only gives me 2, 5 only gives me 0, and 6 only gives me 3. On the y side, 7 only goes to 0, 3 only goes to 6, 2 only goes to 2, and 0 only goes to 5. So this is a one-to-one function. And lastly, on this mapping diagram, 0 goes to 7, 2 goes to 3, 5 goes to 2, 6 goes to 3, and 6 goes to 0. So since this one x value gives me two different y values, it's not even a function, it's just a relation.